Okay, we are looking at tutorial 1, question 4, which is a truss girder. And we have a truss which looks something like this. Where we have these members here. Classic configuration for this type of truss. We've got 2 supports out at either end, and we have a load coming on at this node here of 2, and a load at this point here of 4, and we've called these A and B at our reactions, at our supports. So our reaction 1 and our reaction 2 are A and B, and then we've called these nodes C, D, E, and then F, G, H, J, and K. Okay, we have this dimension here is 4, and then each of these dimensions is 3. So we've got 4 lots of 3. Okay, now the first thing to do is look at the equations of static equilibrium. So we've determined that our reaction 1 plus our reaction 2 have got to equal to 2 plus 4, which is equal to 6. Okay. Now if we take our moments about reaction 1 for our second equation of equilibrium, we get that 2 times its lever arm, which is 3, plus 4 times its lever arm, so this load times its lever arm, which is 3 lots of 3, which is 9, has got to be equal to R2 multiplied by its lever arm, which is the full length. 4 3s are 12. Okay, so R2 is equal to where are we? We've got 6. Okay, let's just do this over 12. Yeah, so 6 plus that is 42 divided by 12. Okay, which is 7 over 2, which is 3.5 if you like. Okay, 7 over 2 would do, but 3.5, which leaves us that R1, since R1 plus R2 must equal 6 from our first equation, R1 is 6 minus 3.5, which leaves us with 2.5, or if you like, 5 over 2. Okay, so those are our reactions, and then how we solve this set of forces in each of these members. There is a axial load. These are pin jointed. Each of these is in a truss is pinned, therefore there's no bending moments in these elements. There's just an axial load in these elements. So we can now start resolving forces, and we start resolving at point A, and we therefore have a reaction at point A, which is coming in at this reaction here, which is 2.5. Therefore, these are all kilonewtons, by the way, and meters. So at this node, we have a horizontal load in this member here and a vertical load in this member here, and our vertical reaction is here. So that means that our load in this element here which is AF, the force in AF must equal 2.5 kilonewtons because there are no other vertical moments. So taking equilibrium about this node, 2.5 coming up has to be 2.5 coming back down. So this is in compression. So 2.5 kilonewtons, and that is in compression. Okay. Again, we could say that there's a nominal reaction R1 horizontal here, but there are no horizontal loads externally on the structure. We've only got vertical loads of 2 and 4, therefore this is equal to 0. Therefore this force in this member here, so that member AC, that has to be equal to 0 too. Okay, so it's neither in compression nor tension. So we've got those two forces, the force in AC being 0 and the force in AF being 2.5. Okay, in the next video we will progress by looking at, I think the sensible thing to do is go up to joint F and resolve forces at joint F.